Good morning, student. Good morning, students. Let's continue the chapter thermal properties of matter. So far in this chapter, we have seen what is heat, what is temperature. Then we have seen the expansion, different types of expansion, the coefficients of expansion, the relation between the coefficient of expansions. And today we will see heat capacity and the specific heat capacity. First of all, let us see what is heat capacity of a body, heat capacity of a substance. What is heat capacity of an body? What is heat capacity of a substance? For that purpose, let us consider we are having two pots. Suppose this is pot A and suppose this is pot B. Both these pots, they carry water, but the amount of water which is carried by both these two pots is different. Suppose this first pot carry water of 1 liter and this second pot that carry water of 3 liter. Let us consider the initial temperature of both these two pots is 20 degrees Celsius. 20 degrees Celsius is the initial temperature of both these two pots, and with the help of an external source like burner, we provide heat to both these two pots, and so their temperature that get increased from 20 degrees Celsius to 21 degrees Celsius. 21 degrees Celsius is the final temperature. Here the change in temperature delta T is 1 degree Celsius. Although the change in temperature for both these two cases is the same, but the amount of heat which is received by both these pots, they are different. And suppose Q1 be the amount of heat which is received by first pot and Q2 be the amount of heat which is received by second pot, then definitely this Q2, the amount of heat which is received by second pot, is 3 times the heat which is received by first pot. Here the heat capacity is different. Heat capacity of both these two bodies is different, and this heat capacity of a body is defined as is defined as quantity of heat, the quantity of heat needed to raise or lower the temperature of the whole body by 1 degree Celsius or 1 degree Kelvin. Here the temperature is get raised or is get lowered by 1 degree Celsius or by 1 degree Celsius. To raise or to lower the temperature by 1 degree Celsius or 1 degree Kelvin, the quantity of heat Q is needed. The quantity of heat Q is needed, and this quantity of heat is nothing but the heat capacity of that particular body. This heat capacity Q, that must be directly proportional to the mass of body. This heat capacity Q is directly proportional to the change in temperature, but for this the change in temperature is 1 degree Celsius. For this, the change in temperature is 1 degree Celsius, or we may say that this Q is directly proportional to mass of the body and change in temperature, which is 1 degree Celsius, and this Q is equal to S into M into del T, where this S is known as the specific heat capacity, and this S is equal to M divided by, sorry, S is equal to Q divided by M into dt. Now, if the mass of substance is unity or 1 kilogram, and if the change in temperature is also unity 1 degree Celsius, then the specific heat capacity of a body is defined as the this Q. What is this Q? This Q is the amount of heat, is defined as the amount of heat per unit mass absorbed or given out by the substance or by the body, by the substance to change its temperature by 1 degree Celsius or 1 degree Kelvin. Here this Q is nothing but the amount of heat. Q is the amount of heat, and M is unity. M is equal to 1 kg, and the change in temperature, that delta T is 1 degree Celsius. For the mass of 1 kilogram means unity, and for the change in temperature 1 degree Celsius means unity. The heat which is absorbed, or this heat which is released by that body to change its temperature by 1 degree Celsius, is nothing but the specific heat capacity. Now again listen the definition of specific heat capacity. The specific heat capacity of a body is defined as the amount of heat per unit mass absorbed or given out by substance to change its temperature by 1 degree Celsius or by 1 degree Kelvin. Then what is the difference between heat capacity and specific heat capacity? For heat capacity, the amount of substance or the body is having its own mass. M is the mass of that body. This mass is not unity. For heat capacity, this mass is not unity. It may be 1 liter, it may be 3 liter, or it may be 1 kilogram, it may be 3 kilogram, the amount, the quantity of that substance is not defined for this heat capacity, but the change in temperature for both these two is the same. So this is the specific heat capacity of a body. Now let us see the specific heat capacity of a gas. Specific heat capacity of a gas. The gas, they are different than that of the solids. The gas, they are not having definite shape or definite size. Now let us consider we are having a container which is having a airtight piston. This piston is movable and gas is enclosed in it. Then with the help of external agency, with the help of this burner, we provide heat, quantity of heat to this gas. If the volume of this gas is unchanged, if this volume remain constant, if this volume remain constant, then the quantity of heat which is absorbed by body is totally utilized to change its internal energy. And suppose we are having the same case of piston, that is the same case of container which is having a airtight piston. Suppose this is the airtight piston and this is the gas, and in this case we provide heat to it by the help of the burner. In this case the pressure is constant. Which thing is constant? The pressure of gas is constant. That pressure should be equal to atmospheric pressure. The pressure inside this container is equal to pressure outside the container, and that should be the atmospheric pressure. Now when heat is given to this gas, then this gas get expand, and as this gas get expand, this gas does some work on this piston. Who does the work? This gas, which is expand, because its volume naturally increases, and when its volume increases, then the work is done by the gas on the piston. So in this case an additional work is done. In this case an additional work is done, but in this case no work is done. Work done by gas is in this case 0. So when that gas is heated, we have to consider which state variable is constant. Is the volume constant or is the pressure constant? When the volume is constant, then the specific heat capacity of gas is known as specific heat capacity at constant volume, and if the pressure is constant, then it is known as specific heat capacity at constant pressure. And from this example you now know that the specific heat capacity of a gas at constant pressure is greater than its specific heat capacity at constant volume, because when the volume of that gas is constant, then in that case no work is done. So the specific heat capacity at constant pressure is greater than the specific heat capacity at constant volume. Sp is greater than Sp. Sp is greater than Sv. There are two types of specific heat capacities of gases. One is known as the principal specific heat capacity. Principal specific heat capacity of one of gas. When the mass is unity, then it is known as the principal specific heat capacity, and when that mass is equal to 1 mole, then that is known as molar specific heat capacity. We will see the principal specific heat capacity and the molar specific heat capacity one by one. First, let us see what is this principal specific heat capacity. Again, this principal specific heat capacity is of two types. The first one is the principal heat capacity, of gas at constant volume. The principal heat capacity at constant volume, it is denoted by Sv. This is defined as the quantity of heat absorbed or released, is defined as the quantity the quantity of heat absorbed or released or reject for the rise or fall of temperature, for the rise or fall of temperature of unit mass of gas through 1 degree Celsius or 1 degree Kelvin. Here for unit mass, then we say that is the principal specific heat capacity of that gas. Now again, let us see the definition. Principal specific heat capacity of a gas at constant volume is defined as the quantity of heat absorbed or released for the rise or fall of temperature of unit mass of gas through 1 degree Celsius or 1 degree Kelvin when its volume is kept constant. Then it is known as specific heat capacity at constant volume. For constant volume, the volume is constant. And the second definition is the specific heat capacity of a gas at constant pressure. Instead of this volume, what we use? We use constant pressure. The definition is the same. What we have to do? We have to do one change, that instead of volume, we may say pressure. So see the second definition, principal specific heat capacity of a gas at constant pressure, and it is denoted by, instead of Sv, it is denoted by Sp. At constant pressure is defined as the quantity of heat absorbed or released for the rise or fall of temperature of unit mass of gas through 1 degree Celsius or through 1 degree Kelvin when its pressure is kept constant. The definition is almost the same. We have to just change one word, that is pressure. Now let's see the second type of specific heat capacity, which is known as molar specific heat capacity of gas. Again, these are of two types. One is known as the molar specific heat capacity at constant volume, and another one is known as molar specific heat capacity of gas at constant pressure. Here the only change is, instead of unit mass, we say that of 1 mole. 1 mole. Instead of just this unit mass, we have to just take one change, that is 1 mole of gas. Then that is known as specific heat capacity of a gas at constant volume or at constant pressure. Now let us see the definition. The molar specific heat capacity of a gas at constant volume is defined as quantity of heat absorbed or released for the rise or fall of temperature of 1 mole of gas through 1 degree Celsius or 1 degree Kelvin when its volume is kept constant. This is known as specific heat capacity of a gas at constant volume. And now instead of volume, let us see the specific heat capacity at constant pressure. Definition is again the same. The specific heat capacity of a gas at constant pressure, instead of volume, the only change is at constant pressure, is defined as the quantity of heat absorbed or released for the rise or fall of temperature of 1 mole of gas through 1 degree Celsius or 1 degree Kelvin when its pressure is kept constant. Instead of volume, what is the change? The pressure is kept constant. This is known as molar specific heat capacity of a gas. Now let us see the relation between principal principal and molar specific heat capacity. The relation is very simple. It is given by this equation. The molar specific heat capacity, the molar specific heat capacity is equal to the product of molecular weight, times the principal specific heat capacity. Here the molar specific heat capacity is denoted by C, the molecular weight is denoted by mu, and the principal specific heat capacity is denoted by S. So From this, one can define the relation between principal and Molar specific heat capacity at constant volume. For constant volume, the molar specific heat capacity at constant volume is denoted by Cv, and this is equal to mu time the principal specific heat capacity at constant volume. And for constant pressure, the molar specific heat capacity is denoted by Cp, and this is equal to mu times Sp, where the Cp is molar specific heat capacity at constant pressure and this Sp is the principal specific heat capacity at constant pressure. I hope you understood this part. From where we started from heat capacity and we end to the specific heat capacity. Thank you.